The stellar population responsible for a kiloparsec-sized superbubble seen in the JWST phantom images of NGC 628. We here study the multi-band properties of a kiloparsec-sized superbubble in the late-type spiral galaxy NGC 628. The superbubble is the largest of many holes seen in the early release images using JWST MIRI filters that trace the polycyclic aromatic hydrocarbon emissions. The superbubble is located in the interarm region 3 kpc from the galactic center in the southeast direction. The shell surrounding the superbubble is detected in high Co and alpha with an expansion velocity of 12 kms and contains as much as 2 × 10⁷ m³ of mass in gas that is mostly in molecular form. We find a clear excess of blue, bright stars inside the bubble as compared to the surrounding disk on the HST-AX images. These excess blue, bright stars are part of a stellar population of 10⁵ m³ mass that is formed over the last 15 million different star formation episodes, as determined from an analysis of color magnitude diagrams using a Bayesian technique. The mechanical power injected by the massive stars of these populations is sufficient to provide the energy necessary for the expansion of the shell gas. Slow and steady, rather than violent, injection of energy is probably the reason for the maintenance of the shell structure over the kiloparsec scale. The expanding shell is currently the site for triggered star formation as inferred from the JWST 21 micron and the alpha images. Next article. The Eurosita Final Equatorial Depth Survey Host Galaxy Demographics of X-ray ANS with Subaru Hyper Cam. We investigate the physical properties, such as star-forming activity, disk VS, bulge nature, galaxy size, and obscuration of 3,796 X-ray selected ANS at 0.2 less than Z less than 0.8 in the EFTS field. Using Subaru Hyper Cam imaging data in the Grizzly bands for SRG Eurosita detected ANS, we measure the structural parameters for GN host galaxies by performing a 2D AN host image decomposition. We then conduct spectral energy distribution fitting to derive stellar mass and rest frame colors for GN hosts. We find that ANS can contribute significantly to the total optical light down to lux 42.5 Hz1. Thus, ignoring the GN component can significantly bias the structural measurements. GN hosts are predominantly star-forming galaxies at long 11.3 solar mass. The bulk of ANS reside in galaxies with significant stellar disks, while their host galaxies become increasingly bulge-dominated and quiescent at long 11.0 solar mass. The size-stellar mass relation of a GN host tends to lie between that of an active star forming and quiescent galaxies, suggesting that the physical mechanism responsible for building the central stellar density also efficiently fueled the black hole growth. The hosts of X-ray and obscured ANS are biased towards face-on systems, and the average ENH is similar to the galactic dust-to-gas ratio, suggesting that some of the obscuration of the nuclei could come from galaxy-scale gas and dust, which may partly account for the deficiency of star-forming disks as host galaxies for the most massive ANS. These results are consistent with a scenario in which the black hole and galaxy grow in mass while transform in structure and star-forming activity, as desired to establish the local scaling relations. Next article. A multi-wavelength view of active galactic nuclei with an emphasis on gamma rays. Next article. At the shape of dark matter halos in the faintest galaxies. Purely collisionless dark matter-only structure formation simulations predict that dark matter halos are typically prolate in their centers and spheroidal towards their outskirts. The addition of gas cooling transforms the central DM shape to be rounder and more oblate. It is not clear, however, whether such shape transformations occur in ultra-faint dwarfs, which have extremely low baryon fractions. We present the first study of the shape and velocity anisotropy of ultra-faint dwarf galaxies that have gas mass fractions of F-gas less than 0.06. These dwarfs are drawn from the Engineering Dwarfs at Galaxy Formation SH project, using high-resolution simulations that allow us to resolve DM halo shapes within the half-light radius. We show that gas-poor ultra-faints retain their pristine prolate DM halo shape even when gas star formation and feedback are included. This could provide a new and robust test of DM models. By contrast, gas-rich ultra-faints become rounder and more oblate within 10 half-light radii. Finally, we find that most of our simulated dwarfs have significant radial velocity anisotropy that rises to beta greater than 0.5 at R3 RAF. The one exception is a dwarf that forms a rotating gas stellar disk because of a planar major merger. Such strong anisotropy should be taken into account when building mass models of gas-poor ultra-faints. Next article. Delving deep, a population of extremely dusty dwarfs observed by JWST. We take advantage of the NIRCam photometric observations available as part of the Cosmic Evolution Early Release Science Survey to identify and analyze very red sources in an effort to discover very dusty star-forming galaxies. We select red galaxies as objects with a SN greater than 3 at 4.4 mu and a SN less than 2 in all JWST and HST filters at lambda less than or equal to 2 mu, which corresponds to F200W, F444W greater than 1.2 considering Sears depths. This selection is ideal to identify very dusty galaxies with stellar masses between 106 to 1010 solar mass at Z less than 5, more massive dusty galaxies at Z equal to 5 to 18, and galaxies at Z greater than 18 due to the Lyman absorption, independently of their dust extinction. Our sample of F200W dropouts contains no strong candidates at Z greater than 6.5. Instead, it consists almost completely of Z less than 2 low-mass galaxies, with a median stellar mass of 107.3 solar mass. These galaxies show an exceptional dust extinction with median value of Av equal to 4.9 mag, completely unexpected given their low stellar mass. The remaining galaxies, which are at Z less than 6.5, show similar large dust extinction, but they are generally more massive, greater than 107.5 solar mass. Next article. Constraining Antaurus sizes with optical and mid-infrared ensemble structure functions. We propose a new method to constrain the size of the dusty torus in broad-line active galactic nuclei using optical and mid-infrared ensemble structure functions. Because of the geometric dilution of the torus, the mid-infrared response to optical continuum variations has suppressed variability with respect to the optical that depends on the geometry of the torus. More extended tori have steeper mirror SFS with respect to the optical SF. We demonstrate the feasibility of this SF approach using simulated GN light curves and a geometric torus model. While it is difficult to use SFS to constrain the orientation and opening angle of the torus due to model degeneracies and insensitivity of the SF on these parameters, the size of the torus can be well determined using this method. Applying this method to the ensemble SFS measured for 587 SDSS quasars with both optical and mere light curves, we measure a best fit torus RL relation of logref equal to 0.49, 0.040, 0.03 log 0.40, 0.01, 0.0 which is in good agreement with dust reverberation mapping measurements in ANDS. Compared with the dust reverberation mapping technique, the SF method is much less demanding in data quality and can be applied to any optical mere light curves for which a lag measurement may not be possible, as long as the variability process and torus structure are stationary. While this SF method does not extract and utilize all information contained in the light curves, it provides an intuitive interpretation for the observed trends of a GN mirror SFS compared with optical SFS. Next article. Assessing model-based carbon and oxygen abundance derivation from ultraviolet emission lines in ANDS. We present an adapted version of the Kothai chemistry UV to derive chemical abundances from emission lines in the ultraviolet for use in narrow line regions of active galactic nuclei. We evaluate different ultraviolet emission line ratios and how different assumptions about the models, including the presence of dust grains, the shape of the incident spectral energy distribution, or the thickness of the gas envelope around the central source, may affect the final estimates as a function of the set of emission lines used. We compare our results with other published recipes for deriving abundances using the same emission lines and show that deriving the carbon to oxygen abundance ratio using CI land in 1909 at OI land 1665 are of emission lines is a robust indicator of the metal content and that is nearly independent of the model assumptions, similar to the case of star-forming regions. Moreover, we show that a prior determination of CO allows for a much more precise determination of the total oxygen abundance using carbon UV lines, as opposed to assuming an arbitrary relationship between OH and CO, which can lead to non-negligible discrepancies. Next article. Star formation laws and efficiencies across 80 nearby galaxies. We measure empirical relationships between the local star formation rate and properties of the star-forming molecular gas on 1.5 kpc scales across 80 nearby galaxies. These relationships, commonly referred to as star formation laws, aim at predicting the local SFR surface density from various combinations of molecular gas surface density, galactic orbital time, molecular cloud free fall time, and the interstellar medium dynamical equilibrium pressure. Leveraging a multi-wavelength database built for the FANGS survey, we measure these quantities consistently across all galaxies and quantify systematic uncertainties stemming from choices of SFR calibrations and the CO to H2 conversion factors. The star formation laws we examined showed 0.3 to 0.4 dex of intrinsic scatter, among which the molecular Kennicutt-Schmidt relation shows a 10% larger scatter than the other three. The slope of this relation ranges beta 0.91.2, implying that the molecular gas depletion time remains roughly constant across the environments probed in our sample. The other relations have shallower slopes, suggesting that the star formation efficiency per orbital time, ESFE per free fall time, and the pressure to SFR surface density ratio may vary systematically with local molecular gas and SFR surface densities. Last but not least, the shapes of the star formation laws depend sensitively on methodological choices. Different choices of SFR calibrations can introduce systematic uncertainties of at least 10 to 15% in the star formation law slopes and 0.15 to 0.25 dex in their normalization, while the Co to H2 conversion factors can additionally produce uncertainties of 20 to 25% for the slope and 0.10 to 0.20 dex for the normalization. Next article. Revisiting the SFR mass relation at Z0 with detailed deep learning-based morphologies. Galaxy morphology is a key parameter in galaxy evolution studies. The enormous number of galaxies which current and future surveys will observe demand of automated methods for morphological classification. Supervised learning techniques have been successfully used for the morphological classification of galaxies from different datasets, including Sloan Digital Sky Survey, mapping galaxies with Apache Point Observatory or Dark Energy Survey. With these proceedings, we release the morphological catalog for a sample of 670,000 SDSS galaxies based on the deep learning models trained on SDSS RGB images with morphological labels from human-based classification catalogs. The released catalog includes binary classifications plus a T-type. The classifications also include K-fold-based uncertainties. This is, as of today, the largest catalog including a T-type classification. As an example of the scientific potential of this classification, we show how the location of the galaxies in the star formation stellar mass plane depends on morphology. This is the first time the SFRM relation is combined with T-type information for such a large sample of galaxies. Next article. SDSS Roman 4 manged the effect of stellar mass and halo mass on the assembly histories of satellite galaxies. We combine an unprecedented manged sample of over 3,000 passive galaxies in the stellar mass range 10 to the power 9, 10 to the power 12 and some with the Sloan Digital Sky Survey group catalog by Tinker to quantify how central and satellite formation quantified by radial profiles in stellar age, pH, and ng feet depends on the stellar mass of the galaxy and the mass of the host halo. After controlling for M-star and MH, the stacked spectra of centrals and satellites beyond the effective radius show small, yet significant differences in multiple spectral features at the 1% level. According to spectral fitting with the code ALF, a primary driver of these differences appears to be ng-Phi variations, suggesting that stellar populations in the outskirts of satellites formed more rapidly than the outer populations of centrals. To probe the physical mechanisms that may be responsible for this signal, we examined how satellite stellar populations depend on MH. We find that satellites in high MH halos show older stellar ages, lower pH, and higher ng-Phi compared to satellites in low MH halos, especially for M-star equal to 10 to the power 9.5, 10 to the power 10.5 and some. These signals lend support to environmentally driven processes that quench satellite galaxies, although variations in the merger histories of central and satellite galaxies also emerge as a viable explanation. Next article. JADE's discovery of extremely high equivalent width Lyman alpha emission from a faint galaxy within an ionized bubble at Z73. We report the discovery of a remarkable Li-alpha emitting galaxy at Z equal to 7.278, JADE's GS 53.16746 to 27.7720, with a U0 498 at UV magnitude 16.7. The spectroscopic redshift is confirmed via rest frame optical lines O Roman 2, H beta and O Roman 3 in its JWST NIRSpec micro shutter assembly spectrum. The Li-alpha line is detected in both lower resolution prism as well as medium resolution G140M grating spectra. The Li-alpha FWHM in the grating is 360 km/s1 and the line peaks within 120 km/s1 of the systemic redshift, indicative of very little neutral gas or dust within the galaxy. We estimate the Li-alpha escape fraction to be 100%. JADE's GSZ7 La has a O-3 O-2 ratio of 8.81.1 and H-beta ratio of 9.62.2, consistent with low metallicity and high ionization parameters. Deep NIRCam imaging also revealed a close companion source, which exhibits similar photometry to that of JADE's GSZ7 LAT, with a photometric excess in the F410N NIRCam image consistent with O-3 H-beta emission at the same redshift. The spectral energy distribution of JADE's GSZ7 LAT indicates a bursty star formation history, with a low stellar mass of 107.15 solar mass. The only explanation of the high U Li-alpha emission seen in JADE's GSZ7 LAT is if it resides in an ionized bubble with radius 3 pmpc. Owing to the faint nature of JADE's GSZ7 LAT, we showed that it is incapable of single-handedly ionizing a bubble large enough. Therefore, we suggest that JADE's GSZ7 LAT may be a part of a larger overdensity, presenting direct evidence of overlapping ionized bubbles at Z greater than 7, allowing us to study the process of reionization across both small and large scales. Next article. Jets in FR0 radio galaxies. The local radial Lauda GN population is dominated by compact sources named FR0s. These sources show features, for example the host type, the mass of the supermassive black hole, and the multi-band nuclear characteristics that are similar to those of Fry radio galaxies. However, in the radio band, while FR0 and Fry share the same nuclear properties, the kiloparsec scale diffuse component dominant in Fry is missing in FR0s. With this project, we would like to study the parsec scale structure in FR0s in comparison with that of Fry sources. To this end, we observed 18 FR0 galaxies with the VLBA at 1.5 and 5 GHz and/or with the EVN at 1.7 GHz and produced detailed images at arxiv resolution of their nuclear emission to study the jet and core structure. All sources have been detected but one. 4 sources are unresolved. Even in these high-resolution images, jets have been detected in all other sources. We derived the distribution of the jet-to-counter-jet ratio of FR0s and found that it is significantly different from that of FRIS, suggesting different jet bulk speed velocities. Combining the present data with published data of FR0 with VLBI observations, we derive that the radio structure of FR0 galaxies shows strong evidence that parsec-scale jets in FR0 sources are mildly relativistic with a bulk velocity in the order of 0.5 c². A jet structure with a thin inner relativistic spine surrounded by a low-velocity sheath could be in agreement with the SMBH and jet launch region properties. Next article. The interplay between accretion galaxy downsizing and the formation of box peanut bulges in TNG50. From the TNG50 cosmological simulation, we build a sample of 191 well-resolved barred galaxies with a stellar mass Lm star greater than 10 at C equal to 0. We search for box peanut bulges in this sample, finding them in 55% of cases. We compute FBP, the BP probability for barred galaxies, as a function of M star, and find that this rises to a plateau as found in observations of nearby galaxies. The transition mass where FBP reaches half the plateau value is log star equal to 10.14, consistent with the observational value within measurement errors. We show that this transition in FBP can be attributed to the youth of the bars at low M star, which is a consequence of downsizing of galaxies. Young bars, being generally shorter and weaker, have not yet had time to form BPS. At high mass, while we find a plateau, the value is at 60%, whereas observations saturate at 100%. We attribute this difference to excessive heating in TNG50 due to merger activity and to numerical resolution effects. BPS in TNG50 tend to occur in galaxies with more quiescent merger histories. As a result, the main driver of whether a bar hosts a BP in TNG50 is not the galaxy mass, but how long and strong the bar is. Separating the BP sample into those that have visibly buckled and those that have not, we find that fully half of BP galaxies show clear signs of buckling, despite the excessive heating and limited vertical resolution of TNG50. Next article. The study of circumgalactic medium with quasar pairs. We have collected 10,025 foreground background quasar pairs with projected distances dp less than 500 kpc from a large quasar catalog of the SDSS Dr. 16Q. We investigate the properties of the Mg Roman 2 absorption lines with WR greater than 0.15 around foreground quasars, including both the loss and transverse absorptions. Both the equivalent width and incident rate of TRA and GI absorption lines are obviously anti-correlated with projected distance. The incident rate of TRA and GI absorption lines is obviously greater than that of loss and GI absorption lines at projected distances dp less than 200 kpc, while the TRA and loss MGI both have similar incident rates at scales dp greater than 200 kpc. The anisotropic radiation from quasars would be the most possible interpretation for the anisotropic absorption around quasars. This could also indicate that the quasar radiation is not obviously impacting the gas halos of quasars at scales dp greater than 200 kpc. Next article. Study of central light distribution in nearby early-type galaxies hosting nuclear star clusters. We present analysis of 63 nearby early-type galaxies hosting nuclear star clusters using the recently discovered parameter central intensity ratio determined from near-infrared observations with the infrared camera of a Spitzer Space Telescope. The series, when combined with filters involving age and bk color of host galaxies, helps identify two distinct classes of galaxies hosting nuclear star clusters. This is independently verified using Gaussian mixture model. SIR shows a positive trend with faint, low mass, and blue galaxies in the sample, while the opposite is true for bright, high mass, and red galaxies, albeit with large scatter. The variation of Siri with central velocity dispersion, absolute B-band magnitude, dynamical mass, and stellar mass of host galaxies suggests that the mass of nuclear star clusters increases with that of host galaxies for faint, low mass, young and blue galaxies in the sample. In bright, high mass, old and red galaxies, on the other hand, the evolution of nuclear star clusters appears complex, with no apparent trends. The analysis also reveals that redder galaxies are more likely to be dominated by the central black hole than the nuclear star clusters, while for bluer galaxies in the sample the situation is quite opposite.